Why would we use mesylate, tesylate, and triflate? Why do we use
Those tosylates?
Yeah, the tosylates.
Good question.
When and why?
So, if we have an alcohol that has chirality,
Okay.
this is usually when, and let's say we want to produce,
Bless you.
there's two types of things we could produce. We could either have cyanide here. So we recognize, okay, cyanide, good nucleophile, is going to attack. One case is still coming forward, the other case it's going back. Alcohol in and of itself isn't a real good leaving group. If you remember from chapter 4, our SN1 reactions, we had to protonate it before it would leave. But when we protonated it, we got a carbocation, and we don't conserve stereochemistry with carbocations. So we want to avoid the SN1 reaction here. So for a tosylate, adding a tosylate makes it a good leaving group. So like TSCl is going to make it big and bulky, and it's going to make it so it could be a good leaving group. So now we can add sodium cyanide in DMSO, which is our solvent, and the cyanide comes in the back, inverts the stereochemistry. So when you use it, you want to use it to make alcohol a good leaving group. Here though, on this hand, we don't want to use it because if we want to get this product, we obviously can't go this route. We're going to have to do something different. So what we can do,
So wait, the first reaction that you did with the tosylate, that's going to be, what, SN1?
no, it's really not, it's probably an S2. The oxygen just attaches to the tosylate group.
But it's attacking from the other side, is that what you're saying? So it's switching the R and S configuration?
This doesn't change anything. Notice how this is going forward.
So the tosylate is just strictly to make the alcohol a good leaving group?
Yeah, exactly.
Okay, and then,
So here, if we wanted to invert it, the first step, if we have PBr3, now the bromine comes in the back, so then when we add sodium cyanide, now the cyanide comes in on the same side. So on your test questions, if you realize, oh, start with an alcohol, my nucleophile's completely inverted, I need to put a tosylate on it, and then just add my nucleophile. If you realize that your nucleophile is on the same stereochemistry as what your alcohol was, they're both coming forward, you would add PBr3, so now the bromine inverts it. This reaction is from chapter 4. And then you add your nucleophile, so then it comes to double inversion. So your stereochemistry is, yeah. I can't think what the word is.
so would she give you like the butanol, the 2-butanol? And then say, how do I get to the,
Yeah, what steps? This could be like a simple synthesis question.
okay, and then so this, if you want if you want the opposite of what you have for when you want to add your CN group,
Mm-hmm.
then you're going to do a tosylate,
And then nucleophile.
because then that'll change it to go away from you.
Mm-hmm.
That's the reason why we would make it a good leaving group, to change
Yeah,
the direction of.
To make this react, you have to make alcohol a good leaving group.
Okay,
This one from chapter 4 we know just works. The bromine's going to replace the alcohol.
well maybe I'm not catching it then, so why are we doing just PBr3 and the tosylate on the other side? I see what you're saying, like with the stereochemistry, you want to keep it, so like your alcohol right there is coming out of the board, right?
Mm-hmm.
So if you want to, what's CN, cyanide?
Mm-hmm.
If you want your cyanide to continue the same stereochemical, or the same stereochemistry,
Mm-hmm.
it's coming out at you, you're not going to use the tosylate. You're just going to use the PBr.
Yeah, and it's more the fact that PBr3, as you remember, it's just reaction we know from chapter 4 does an inversion of stereochemistry. So you could add a tosylate and then add PBr3 to it, but it's unnecessary because we know this works. You can't just add cyanide to this one to invert it, because this alcohol is not a good enough leaving group yet. Whereas this reaction, the mechanism, makes the alcohol a good leaving group by itself.
Could we have the same thing on the left side of the board if we just do tosylate and CN? We're not using the PBr3?
Oh, if we did that, you're gonna get this, because
You just-
tosylate you would get this thing. You could do, I mean, this is unnecessary, but you could say, okay, tosylate, and you get this alcohol here, and then add PBr3. But that's unnecessary because it's gonna give you the same thing.
So in your, John, I'm sorry if I'm not getting this, but you have the stereochemistry flip when you put the BR there, but then it
Yeah.
flips them back
Mm-hmm.
when you're doing it. So what makes that do that? I don't ever
It's just an
remember.
SN2. So this one, chapter 4, it's like SOCl2.
Uh-huh.
Do you remember that mechanism?
Yeah.
PBr3 is the same thing.
Mhm.
Your chlorine, here, I mean, I could say you use SOCl2, chlorine goes back. It's just the mechanism. Because the alcohol first attacks the sulfur, then chlorine comes.
Okay.
So you could use SOCl2 instead of PBr.
PBr3, yeah.
Okay. And then the NaCN, it can just be any nucleophile, doesn't have to be that.
Yeah, it just depends on what she asked you. If she had azide here, or your
Could it just be
carbon
like,
boxylate.
could it just be like a halogen right there or something? Or no?
Yeah, you could have iodine to it, because iodine's a better nucleophile than bromine. But you probably couldn't add chlorine just because chlorine isn't a good nucleophile compared to bromine.
Gotcha.
So, and actually, retract what I said, you can't do tosylate, because if you add tosylate, then it would make the alcohol not be able to react with PBr3. So you can't do tosylate this way.
And then maybe it's the DMSO would be the solvent, right?
Mm-hmm.
And
DMSO
when-
is just a solvent.
Is that like, are there certain situations when you use DMSO or something else, or is that kind of the same?
DMSO is probably your safe bet to use all the time,
Okay.
but SN2 reactions, you use DMSO as your solvent. So SN2 is when you have an inversion of the stereochemistry there.
Okay. SN2, you have the inversion. So which one do you not have the inversion?
Well, adding the,
Well, okay, that's SN2 right there too.
this here is just not SN2. This really,
But from when the tosylate is attached down to there, that's
Yeah.
SN2.
exactly.
And then that's SN2, so we just have to figure out, okay. And does it matter which, if you use a tosylate or triflate or,
No, it
doesn't
doesn't
matter any
matter.
of those?
They're all,
So she just wanted to pick 3?
yeah, there's probably even more than that, but
Yeah.
as long as you recognize them. But
Okay.
those might be the common ones.
Can you draw them out? Can you like, you know?
I don't know the structures of them.
Because she has that as one of the structures, but I don't know how they differ from, I know they all have that, was that the benzene ring? Or
So
the,
your CF3SO2 is probably, looks like this. That's probably something like that,
okay.
I'd imagine.